All right, so again, we just did kind of the conversions between moles and mass. We can do moles and particles. Because we know 1 mole is equal to 6.02 times 10 to the 23rd particles, again, that's Avogadro's number, we can understand, hopefully, that we have two, that's our unit equality, we have two conversion factors. One is 1 mole per 6.02 times 10 to the 23rd particles, or 6.02 times 10 to the 23rd particles per 1 mole. Okay, so those are my conversion factors. Now, obviously, once you're given something, let me go ahead and I don't like the way that it kind of comes out and swipes out when I click on my screen. But let me go ahead and give it. I've got 3.95 moles. So 3.95 moles of copper nitrate. To be honest, in this situation, I don't even have to mess with the periodic table. When I'm doing moles and grams, I do have to look to the periodic table because I have to use the conversion factor from the unit equality for grams and moles conversions. But with this one, if I have, let me not even call it particles. If I have 3.95 moles of copper nitrate, how many formula units is it? Because again, it's an ionic compound. Again, I'm probably going to call it molecules most of the time as well, but formula units, okay? So, how do I do it? Well, X line. You're going to hear me keep saying X line, X line, X line. X line. Moles goes in the bottom because that's the unit I'm given. Formula units goes on top because that's what I'm looking for. Notice I always have 1. I'm always going to have 1 when I do a conversion between moles and something else. 1 mole. And then the number I'm going to use for formula units is 6.02 times 10 to the 23rd. I'm using this unit equality, and well, that conversion factor I should say. Now because the 6.02 times 10 to the 23rd is on the numerator, or in the numerator, then I'm going to multiply by it. So I've got my calculator again. 3.95 times 6.02, and remember we use EE or EXP, 23rd, and we multiply them and we get 2.38 times 10 to the 24th formula units. Now does that make sense? This number is larger than 6.02 times 10 to the 23rd. I hope we all recognize that it is larger because the exponent is larger. So even though that 2.38 is smaller than 6.02, because it's times 10 to the 24th, it's larger. So this number is larger than 6.02 times 10 to the 23rd, which makes sense because I have more than 1 mole. So there's my conversion. There's using my unit equalities for a moles and particles conversion. Obviously, I don't want to spend too much time kind of reviewing, and I'll do that on a review, but I could do the vice versa. I could go from moles, particles I should say, to moles, okay? The next type is moles and volume. So we haven't mentioned that yet, but moles and volume, this is only for gases at STP. And so the volume of gases, which of course in this case is going to be liters at STP. Gases are affected by temperature and pressure, so that has to be at standard temperature and pressure. Standard temperature and pressure, 0 degrees Celsius, and standard temperature pressure is 1 atmosphere. So 0 degrees Celsius, 1 atmosphere is standard temperature and pressure. But basically what happens with this is 1 mole of any gas at STP is 22.4 liters. So this right here becomes our unit equality. 1 mole is 22.4 liters. So I could say 1 mole per 22.4 liters, or I could say 22.4 liters per 1 mole. All right, there's my conversion factors. Now, well, I think I did one here. What do I have? Oh, I can't read my writing. It doesn't matter. Let me go ahead and just do something else. let's say it's, well, it doesn't matter which one we're doing. Let's do 75.2 liters of oxygen, and I want to know how many moles that is. Well, all we're doing, X line, X line, X line, X line. Liters in the denominator because that's what's given and we want it to cancel. Moles on top. The number for moles is always 1. Please notice that for all these things, the moles is always 1. So 1 mole. And then I say to myself, self, what's the liters? 22.4. So again, this is the, whoops, not that one. This one is the conversion factor I'm going to be using. Again, because the 22.4 is in the denominator, I'm going to divide. So let me take out my trusty calculator over here, 75.2. Divide that by 22.4, and I get 3.36 moles of O2. There would be my answer for that one. Again, let the X line tell you, should you be multiplying like I am in this case because it's on the top, or should I be dividing because it's in the bottom or the denominator in this one? Let the labels do the talking. I always go X line, then I go labels, then I start filling them in. I always fill in the 1 for moles, and then I fill in whatever it might be for the other one. We'll look at some more examples as we go through.